Well, the old turbine's been running up there for nearly 10 years with no problems. But the manual says it's now time for a serious tune-up and maintenance inspection. So I better get to it while the weather's still fair. The owner's manual says to do a minor version of this maintenance and inspection every 2 years. But this video is about the major version that happens every 10 years. Now, even though I will be covering most of the information here, there's nothing like having the factory owner's manual for all the steps and details. And even though I'll be working on a specific brand, a lot of the information could be applied to any brand of a similar design and size. Now, the two most important things on the list: re-grease the hub bearings and check the blades for possible replacement. Then I'll deal with all the rest of the items as I go along. So to begin, I want to get to those hub bearings. With this Allen wrench, I'm going to remove this cone, the spinner, and I've already made my mind up that I'm going to replace these blades, so I'm going to remove them too. But if I decide that the blades don't need to be replaced yet, these nuts and bolts still need to be retorqued down to their original tightness, and I'll show that later on in the video. The manual says the blades become gradually degraded over time, so I would make a careful inspection of the blades, looking for any cracks here at the blade root, then inspect the entire blade surface for damage from hail, bugs, debris, especially along the leading edge. If I found any cracks or damage, I would replace the blades. And for these Bergey blades, there's another type of degradation over time, from flexing and from exposure to the sun's UV radiation. One result is that the blades become more flexible. In a worst case scenario, becoming so flexible they could bend in during operation and actually whack against the tower. Now, I'm just going to play it safe, so I ordered a new set of blades from Bergey. They were a bit over $400. Ouch. For folks familiar with automobile mechanics, it'll become clear soon enough here that this hub is very much similar to a common type on cars and trucks, like the front wheel hubs on a rear wheel drive vehicle. And I never want to reuse cotter pins. Get new ones every time. So after removing that castle nut, I'm ready to remove this outer bearing roller cage. Now, this isn't the actual footage. The real bearing that came out didn't have any grease on it. It was pretty much dry. This is the new one that I'm putting in, all repacked with new grease. If I want to reuse the old bearing and just clean it up and repack it with new grease, I should put this away in something to keep it clean. I'm ready to remove the hub. I want to grab it evenly and pull clean straight. It's got powerful magnets in there that are holding it back. Now, two things to point out here about this bearing and shaft. This is the original bearing. You see those kind of discolored marks on the rollers? That's from being used for a long time, likely without enough grease. It's a bit iffy if they're okay to reuse. They're only $10, so I'm just going to get new ones. The other thing to notice is how loose this bearing is on the shaft. It's not supposed to be loose like that. The inner part is spinning on the shaft and it's supposed to be tight, and only the rollers are supposed to turn like that. If nothing is done about it, the shaft will continue to wear down and the whole thing will get looser, and that could allow vibrations in the turbine to be magnified, shortening the life of the bearings and the turbine as a whole. And in the meantime, the machine won't run as smooth or as quiet. So here's an old remedy that I've used many times before on automobiles, and it's making hundreds of little tiny dents, little crater dimples, and their edges are raised up, making the shaft bigger, so the bearing will fit on more tightly. The tool I'm using is an old Phillips screwdriver that was pretty hard metal, but the handle had broken off, and I sharpened it to a new point, and it needs to be sharpened sometimes partway through the process. Got to keep a sharp point on it. It might take a little practice on how hard to hit the hammer and make the dimples, but
It's better to have many little dimples than a few big ones.
it goes on too hard at first and just skid back and forth across, and it'll cut the top of those craters off and make it just right. But if I hit the hammer too hard and made the dimples too big, I could always take a file and just go lightly over the crater area, just slightly, and then try it again. If I go too far, I've got to dimple it all over again. Now when I've got it right, it should be just like this, where it's a little bit hard to slide across, but not too hard. The inner bearing was too loose too on the shaft, and I want to do the same dimpling here. But dimpling this one requires a little more preparation care. I don't want to be pounding that next to all these copper windings. I could ruin the turbine's electric system. So I first installed 2 layers of duct tape, Gorilla Tape, around those copper wires so that when I'm doing my pounding, the screwdriver is leaning up against the tape and not the copper wires. This is where having a nice sharp point on that punch really helps keep it from skidding back in there. The reason there's no tape there now is because I've already done it. I'm just going through the motions here. But if I made the dimples too big and this is hard to get on, I wouldn't force it on because it's hard to pry it back out of there. This one ended up just right. It's a bit too hard to pull back off, but I could do it. I skid it across again a few more times. It gets a little bit easier each time. But if I couldn't get it on, I could again use the file, making sure I stay away from those copper windings with that file. This is how it should be when it's just right. A bit hard to push on and pull off. Not too tight, not too loose. If I decided to replace the bearings, then I need to remove these bearing races. But if I didn't feel confident to do it myself, I could take it to a local automotive machine shop where it'd be simple and not expensive to do. Now, I've done this before many times, so I'm just going to do it myself. And I know this way is a bit crude and rough, but it works, and just look at it this way. Pretend that we're on our way to California and we broke down, got to use the tools we have. So in pounding this out, I want to alternate side to side so that the bearing doesn't get cockeyed in there. Hey, very funny. So that was the inner bearing race, now the outer bearing race. I bought the more expensive premium bearing, but it was still less than $15. And these bearings are a very common type, and the number they are is located usually on the side here. Now, even though this is a crude in the dirt operation, it's still really important to keep these new bearings or the old clean ones from dirt, debris, contamination. Oh crap, do you see that? The magnets grabbed the damn thing out of my hand. They're very strong. So you can see I really want to watch out with the steel pieces around those magnets. It could pull it in and crack the magnets or crush a finger. I want to keep the 2 bearing pieces together, so I mark this for the inner bearing. The idea here is to not get the race cockeyed, but just gradually get it in evenly as possible. To install this new race, I'm going to use my official hillbilly drift method. Notice I keep alternating the sides so I don't get it cockeyed and I go down all the way. And of course I want that entire hull and race area thoroughly washed and cleaned both before and after the race installation. Here's the new bearing roller cage, all packed with new grease. Set it in there. And here's the new seal. It has two sides, but it only goes in one way as shown. I want to treat this seal gently and pound it in evenly, just like the races. And if I had a plastic hammer, I would have used that. Now to install the race on the other side. Notice the hole is stuffed with new grease. That's the way it came from the factory, and so I'm just going to copy it. I don't know if it helps. Make sure that's all the way down. Pounding it in makes a different sound when it bottoms out. Okay, so that takes care of the hub bearings. But now I need to consider dealing with the yaw bearings. It's a similar design to the hub bearings, and they're located up in here at the top of the tower stub. And they enable the turbine to pivot around when the wind direction changes. Now, I don't have any video of re-greasing the yaw bearings, but it's very much the same as the hub bearings, and it pretty much would be self-explanatory after seeing that. But I will show later in the video how to gain access to those yaw bearings. Another maintenance item is located just below the yaw bearings, and it's the slip rings, which lets the turbine's electrical output get around the pivot to continue on down the tower. They will be exposed for inspection when the parts are removed to deal with the yaw bearings. I'd be looking for tight electrical connections, signs of heat from poor brush contact, and excessive wear on the rubbing parts. Here I'm going to reinstall the hub. First I'm going to wipe a small thin amount of grease on that lip ridge there for the seal. Just a thin amount, no extra, and a little bit more on the rubber seal itself, which is kind of off camera, sorry about that. With a firm, even grip, I want to guide this straight down, as straight as I can, and the magnets are going to grab it. So I watch where my fingers are. Next, the outer bearings roller cage, cleaned and repacked with new grease. Then I'm going to install the castle nut, and automotive gearhead types would notice that there's no flat washer underneath there. And Bergey says that's right, there isn't. Now, newly packed bearings will give a false reading of being snug enough with that castle nut when they really aren't. So I want to keep spinning the hub as I tighten this nut down, and I want to tighten the nut down snug and keep spinning it to settle the new grease. It's very important so that I get a true reading of what's tight and what's loose on this castle nut. And I want to make sure that the electric brake or stop switch is off so that this hub can turn freely. Then I want to back the nut off so it's slightly loose. If I back this nut off even a little bit more, there's one of the cotter pin hole choices, and there's the other cotter pin hole choice. There's tight, and Bergey wants it slightly backed off from tight, and that would be this cotter pin hole. That's the one I'm going to use. I want to emphasize how important it is that this castle nut ends up at the correct tightness. Now this 3/16 cotter pin is not the ordinary hardware store steel type. It's stainless steel, much harder to bend, much harder to cut. And I couldn't find one locally, so I found one easy enough on eBay. The link to the eBay page where I bought the cotter pin is in the description below. What I'm doing here is I'm getting the head of the cotter pin tucked in closer to the center because it can't stick out or it's going to rub against this dust cap. Same with this other end. I might have to cut one or both pieces to make them short enough to bend one over. That's the way I did it, but it was a pain to get one of them just long enough to bend down. The way it came from the factory, it looked like they just bent this one up over the top. And that way simpler and easier because it doesn't matter how long it is then. But whichever way I do it, the main thing is to make sure that the ends don't stick out and rub on this cap, because the cap is spinning with the rotor, but the cotter pin and castle nuts stay still. I want to pound this cap down gently and evenly, so I keep going around and around till it sits flat all the way around. So this is about installing new blades. But if I was just going to retorque my old blades, which in the Bergey you're supposed to do every couple years, I'll show that part a little bit further on here. The new blades come with all new hardware and no Loctite is needed. I don't want to be tightening these down all the way yet, I just want them barely snug, because the blades might need some adjusting before they're torqued all the way down tight. This blade adjustment has to do with the distance between each blade tip, all three of them measured from tip to tip. The goal is to get the distance between the blades to all be within 1/4 of an inch of each other. If they aren't, then I'd pick out the longest distance set and put my hands on each one and pull them together, and that area will get smaller and one or the other or both of the other sides will get larger. And I just keep repeating the process until I get all three blade distances within 1/4 of an inch of each other. If I'm having difficulty keeping the blades where I moved them, I could try slightly tightening up the bolts and try it again. Now the owner's manual suggests a different way. They say to tighten up one blade and then just move the other two to come to the equal distances. I kept working with mine till I got them within 1/16 of an inch, and I can tell my turbine runs smoother than it ever has.
Oh yeah.
As I get the blades distances close together as I want, I keep tightening down these bolts a little more and a little more until finally I'm going to torque them down, but stopping along the way several times to recheck the distance between the blade tips, because they could drift and change as I keep tightening the blades down more and more. When I'm ready to finally torque the bolts down, I do it in 2 steps, first to 20 foot-pounds, then to 45. And Bergey wants that one first, that one second, and that one last. All the details are in the owner's manual. I'll make one final check on the blade tip distances. The nose cone spinner, it's kind of like the cherry on top. Bergey recommends using Loctite on these. I'd go with low strength purple. There's a rubber gasket underneath that flat washer. I don't want to over tighten them, just snug. There's a bit more to go, but you know what? It's been a long day, so I'm going to head on back up to the ranch and grab some grub and hit the hay. I'll see you in the morning. You mean the windmill's all done? It looks so good there in the morning sky. What?
Okay, I'm up.
Okay, ready for the home stretch here. This part applies to the 2-year and 10-year inspections and how to gain access to the slip rings and the yaw bearings, which requires removing that white round body covering called the nacelle. Okay, so for inspections, just check that these are tight. For nacelle removal, take those bolts out. Same with this one. Then at the back rear is these 2 tail rubber bumpers. There's one there. Check it for tightness or remove it. There's the other one. Check bolt for tightness or remove it. It looks like the same one, but really there's 2 of them. I folded the tail over, and the one we first looked at's now underneath there. Next are the tail pivot pins and the cotter pins. Make sure nothing's worn out or loose there. For nacelle removal, that cotter pin has to be taken off and the pin has to be driven out so the tail itself can be removed. For inspection, check this one just like the other side for looseness or anything worn. Those are stainless steel cotter pins, by the way. The nacelle is now ready to be removed. Okay, now the wind turbine is held onto the tower by what they call the tower adapter, and it's held on to the tower by these 6 bolts, and they need to be torqued down to 45 foot-pounds, and it's a good idea to check them now while it's on the ground. I used medium strength Loctite, so they're probably not going to be loose, but it doesn't hurt to check. Now for the tail inspection. What I'm looking for here is tight screws. They were supposed to be Loctited originally, and also look for any cracks in the sheet steel there. And the tail boom itself, this long bar, it's pretty strong. I wouldn't expect any problems towards this end of it. But back up towards the root where it connects onto the turbine body, I would look real close at all these welds, looking for any stressed cracks. One particular place that gets a lot of stress that's been welded together is right along there. I'd look at that real close for any cracks going on. Same on the other side. This weld looks like it could have been done better, especially up there. It didn't go all the way up to the top, but I don't see any cracks, so I'm going to call it good. Oops, I just noticed that tail pivot pin collar. It's on the bottom and it should have been driven in from the top. The whole pin is upside down. So that's all I'm going to cover, but the owner's manual does have more details.